Hello, this is Darren Pulsipher, Chief Solution Architect of Public Sector at Intel, and welcome to Embracing Digital Transformation, where we investigate effective change leveraging people, process, and technology. On today's episode, we're going to talk about security and data transformation with Jesse Schrater, Security Manager at Intel. Hey, Jesse, welcome.
Thanks. Good to be here, Darren.
Hey, well, we've worked together for a long time. And just recently you gave this great presentation on security at Intel and some of the new technologies we have coming out in hardware. And I said, I got to get Jesse on the show. We got to talk about this. It's really cool stuff. So why don't you kick us off? Why do we even care about security today? What's going on in the security realm?
Yeah, well, it's become one of those things that everybody knows security is important, but what's kind of driving it? I mean, if you think about how incredibly connected the world has become with all of the devices and things like that, and it's just driving a massive exponential growth in the amount of data that we have to manage. And that's a good thing, right? I mean, because we can gain so many insights from that data, but it's also a challenge to manage, and it drives us to want to leverage a lot of the new kind of computing capabilities, like cloud and analytics and edge computing and things like that. But that can drive additional complexity also. And anytime something is more complex and anytime there's more volume, that also can create additional risk of exposure of the wrong things to the wrong people at the wrong time. And obviously, people say, there's that saying, why do hackers attack the data center? Well, that's because that's where all the data is.
That's right.
And so, this is what we're trying to deal with. And there's a couple trends that I think are coming out of that really Intel is focused on. And one is this concept of encrypting everything. Basically, encrypt all your data wherever it is. That's maybe a long-term objective. It's not something you can do overnight, but at the same time, that's the direction we want to go. The more we can keep data encrypted, the harder it is for people to get their hands on it. And another part of it is isolating workloads and data, both at the network level, but also even within the system, keeping them isolated from each other. The more you can isolate, the more, if there is some sort of breach or compromise, it's going to be limited to a smaller set. And so you're containing that, that damage. One of the things that's really big for Intel is this concept of building a chain of trust. In other words, starting with a trusted foundation, a trusted platform, and then validating the levels of the stack up from there so you can be sure that what you're running is what you expect to be running and where you expect to be running it. And all of this is going to help the organizations deal with the increasing regulatory requirements that come along with societies wanting to make sure that the private data and important data and sensitive data is being protected.
So three major trends: trust, hardware root of trust type of concept, attestation, encrypting everything, right? And then workload isolation. Those are the three main things. And then compliance is kind of driving a lot of that. So that's what we're seeing in the ecosystem today.
Exactly.
Really interesting. Now, I know because of COVID-19, and we did a whole series on the podcast on remote work and how to manage that, security was kind of thrown to the side during this. Everyone needs to go on VDI, or everyone needs to go VPN, or everyone's working from home now. And I've talked to a lot of CIOs, and they all say, well, yeah, now we got to look at security now that we have everyone spread all over the place.
That's a good point. That might happen in a temporary moment, but that's obviously not a sustainable model, right? And what we're seeing is with all of this access to data, it can really be a catalyst for business transformation. And we know organizations want to transform the way they handle and utilize data, but security really has to go hand in hand with that, because if you're transforming the way your business processes work with data, but you're not keeping the security controls in place and the complying with regulations and things like that, then you're setting yourself up for additional problems down the road. So the more you can address security along the way with your deployments and your implementations, the more you're going to be able to more completely transform the way you do business in a sustainable fashion.
Right now, that all requires work, right? It just doesn't come for free. But the things you mentioned the other day when we talked about security and some of the new things, Intel in this space has a lot of really great technology that will make it at least easier to do
Yeah,
without just putting someone's laptop completely off the network and say, now it's completely secure. It's not talking
right,
to anything, right?
right. Air gaps always work pretty well.
But not very, it doesn't work very well when you want to talk to other people. So
No.
explain, let's dive into some of the technology that Intel has that helps in this space.
Yeah. Well, so we've long known. I think about this issue of encrypting data, and you really want to encrypt data through all of its phases. And we've long known attackers. Back in a long time ago, if attackers wanted to get access to data, one of the easiest things to do was just to snoop the network, right? All the bits going across the line. So what did we do? We started encrypting the network, and that made that part harder. So then they started breaking into the data center and pulling data out of the next most obvious place, which was the databases, right? The places where the data was stored. And so what have we started doing? We encrypt our storage. The problem is, and so now, attackers are saying, well, how else can I get that data? And the challenge is that when you send encrypted data over the network, it's encrypted across the network, but it has to arrive at an endpoint. And when it arrives at an endpoint, it gets pulled up into memory and gets decrypted so that the system can do some processing with it. And at that point, a sophisticated attack that can get, root access or leverage various ways of getting into the low-level internals of the system could potentially grab or manipulate that data at that point of processing. And we call that data in use. And this really is the new frontier, both for attackers, because this is sort of where they've been pushed to target, but also for us in defending that space. We have some pretty exciting and innovative new capabilities that we're building into our processors to help data owners, application owners, service providers, kind of the whole ecosystem take advantage of and help close those potential vulnerabilities.
Great. So at rest, in transit, and in use. So
Yeah,
in use is the new area that we need to worry about. Okay.
absolutely.
So what do we do?
Well, so, just taking a little more look at what happens. Well, a lot of these types of attacks, what they're doing is they're using privilege escalations down at the operating system or hypervisor layers. And, they could be coming in through a guest OS or a host OS, even physical hardware access on the server. And these could be, your classic hacker malware type intrusions. These could be third parties, competitors, et cetera, who sort of happen to be in the same space and can get access to some of the data because maybe it's been shared in some way. And these could even be malicious insiders. An admin, a sysadmin at a service provider, a hosting provider, has access to the low-level operating system. And if they use that internal privilege escalation, then essentially they can get access into the applications and the memory while it's being processed. So that's what we really need to target. So Intel has built a new technology into our processors. We call it Intel Software Guard Extensions, or SGX. And this is part of the confidential computing paradigm that's really exploding around the market right now as businesses are trying to transform their data and keep it secure, keep it private. And what SGX does is it addresses those new types of attacks that we're seeing. And the way it does it is it allows the application to speak directly to the processor and the encrypted memory bypassing the operating system, the hypervisor, essentially everything else on the system. And so even if you had a breach in your operating system or your hypervisor or other applications through that malware or malicious insiders or whatever, it almost doesn't matter, because they wouldn't be able to get access to that data anyway, because the operating system itself doesn't have visibility to that data. So
Wow.
yeah, you can put code and data into these enclaves, we call them, and essentially they're transparent to the rest of the system, and therefore you don't have to trust the provider, you don't have to trust the rest of the system stack. You can basically operate as though they have been compromised already, and your code and data is going to remain confidential, and it's also going to remain unmanipulated, right? Unchanged. It will have integrity.
So this feeds into that big, the buzzword today is zero trust, right?
Mm.
This really gives me zero trust all the way down into the CPU, including my full stack that is supporting it. So if I have an application running in a VM on top of an OS, I don't care
Yeah,
if they've been
you're
compromised. That's pretty cool.
you're right. Zero trust is a buzzword, and obviously as a security guy, I I
I bet
um,
you cringe at
I
that.
cringe at zero. How about significantly reduced?
You're
we
such a
there's
purist, man. I mean, come
we're
on.
we're trying to make it so that you have to trust the least number of things possible, right? And SGX takes you further down that path than anything else I've ever seen for the data center, because all you have to trust at this point is your own application and the processor itself, and everything else on that system stack is kind of out of the, what we say, out of the trust boundary. And if you think about it, cloud service providers love this concept, and that's why they're flocking to it and deploying these kinds of solutions, because they want to be able to tell their customers that I couldn't access your data even if I wanted to. Now, of course, they don't want to, but people want that type of assurance that even if somebody was malicious, or even if there was some sort of, I don't know, external government pressure or whatever, that cloud service provider just flat out does not have access to that data in any circumstances. And that's a powerful capability to be able to offer your customers.
Oh, that is very powerful. Now, some of the cloud service providers have already adopted this, correct? Like Azure has adopted this already, right?
Absolutely. So we have Intel SGX is actually already out in a broad swath of cloud service providers and software vendors that are building solutions, and so. But in some ways, we're just getting started, because even though this technology has been out there for a number of years and we've built an ecosystem, we're bringing new capabilities in our latest upcoming Ice Lake processors, which is our 3rd generation Xeon, that are really just going to expand its capabilities, its ability to scale to large enterprise type workloads even further. It's going to be able to protect much larger chunks of memory with better performance, and across a much broader footprint in the mainstream data center. And we were part of one of the founding members of the Confidential Computing Consortium, which is part of the Linux Foundation, and it's sort of a who's who in the cloud and security space. Most of the big cloud service providers, lots of software providers, and even our other silicon competitors, we're all in there together, working on these type of trusted execution environment solutions, and building standards, building better ways of consistently handling this type of capability, and really just growing the awareness of both the necessity of confidential computing and really the value that it can bring to a business.
All right, so let's talk about the practicality of this, right?
Mm-hmm.
Does this mean that can I just go and buy, either in the cloud or buy SGX in my processor and then just drop my application in there and it runs fine? Do I have to rewrite code? I mean,
Yeah.
is this a heavy lift for me, or is it a light lift? I mean, can I take advantage of it right away? Tell me some of the practicalities around it.
Sure. Intel SGX provides a lot of optionality in this space, depending on what the data owner is looking for. So Intel SGX is definitely gives the most granular level of control. So somebody who has very sensitive code and data and really wants to lock that sucker down as much as possible, SGX is going to allow them to do that, because they can essentially, within their application, um, pare it down to just the code and data that they want to keep
Oh,
isolated
wow.
from the entire rest of the system. It's not even just an application. It could even be a sub part of an application.
That's pretty incredible. So I can have in one application, I can carve off a part of it and say ultra protection, ultra confidential, can't share data
Exactly.
with any other parts of the process.
So
That's
that
there.
even
That's
if you
cool.
had a failure or a breach in some other part of the application, even that wouldn't expose that sensitive data, right? So
Wow.
that's that really granular level of control. Now, that does require you to
Yeah, I have to make
develop
code
that
changes,
application with
right?
that capability, right? If you want your application to be that smart, then it's going to have to be written for that purpose. We have seen in the ecosystem all these abstraction layers and SDKs being provided, from Azure, and there's a lot of stuff in the Confidential Computing Consortium, open source stuff that's making the development of that a lot easier. So, it's not like you're doing low-level assembly language type coding. There's nice, easy to use, and it's also expanding out to more languages and more operating environments, etc.
But I don't
That's
have
that.
to do that, right?
No, that's right. That's that most control side. At
Gotcha.
the other side, the kind of the fast path, lift and shift, take your application and drop it over into a more secure environment. We're also seeing the ecosystem respond with that. And what they're doing is they're essentially creating these SGX aware containers. And I'm using the container term loosely. Yes, it does apply to things like Kubernetes, but it also applies more generically to basically a very lightweight, small operating system that could run in a VM or something like that. And then you drop your unmodified application into that environment. It's the only thing running in that environment. And so the little mini OS or the mini container is SGX aware and creates that enclave, but the application itself just thinks it's
Doesn't know.
running in a native environment.
Oh, so that's what I want, right? Because I want a light lift because, well, a couple of reasons. First off, I'm an IT professional and I have hundreds or if not thousands of applications. I just don't have the time. And I don't want to spend a year and a half, rewriting applications or even more than that to get them to run. So I love that. That's
Mhm.
cool.
Yeah, and that's really something that our ecosystem partners have made a lot of progress in. There's things like Fortanix out there, Graphene, Scone. There's all of these new capabilities that are out there. Many of them are open source. Some of them are proprietary, but come with all of the services already baked in. Microsoft Azure Confidential Computing is out there, and they offer both the whole range, right? Everything from lift and shift type solutions with SGX all the way down to the SDKs that allow you to develop your application directly for it and to land it in their environment where you don't even have to manage the hardware and those low-level stacks. So you kind of have the full set of options. People shouldn't be afraid of the complexities of SGX because there certainly are ways for them to access those security properties in easier ways, but they also should take confidence in the fact that if they need to secure something very sensitive like a critical machine learning algorithm or their keys, their
Or even
encryption
their
keys.
encryption keys, right? I mean, that's an
Exactly.
easy one.
Those things are going to be able to be handled with that very granular level of protection.
Oh, that's great. Now you said ecosystem.
Mhm.
Pretty big ecosystem. It sounds like, I mean, SGX has been around for some time,
Yeah.
right? So we already have a very strong ecosystem around this. Can you mention any more about the ecosystem? What do you
Yeah,
have
well,
around?
So we originally brought SGX first into the client space, and then started bringing it into the data center with our single socket platforms. And I mean, I'll just be honest. The reason for that is because it's easier to develop a complex technology like this when you have a single socket. You just have one processor, rather than when you have multiple that have to be able to, process the data and share data and stuff. So we started with the first, simplest solution, and then have been working to expand it. And so it is out there. It's been tested. It's been through the ringer. There are literally hundreds of research papers that have been written about it, and it's been continued to be hardened over time with updates as various vulnerabilities or challenges are discovered, and so we just make it that much more robust. So it has the advantages of not really being the new kid on the block. It really was kind of the foundational and original solution for confidential computing. What we're doing now with Ice Lake is really bringing it into the mainstream, that full line of Xeons with giant enclaves and way more cores and all of the things that people want to really run their big workloads. So it's no longer focused just in these kind of little sensitive areas, but it can take on the big stuff now.
So it's almost like taking your kid and sending them off into the world, right?
That's right. We've trained them up and we've prepared them, and now they're ready to do great things.
It's ready to do great things. This is wonderful technology. Especially when I think about public sector, the federal government, state and local governments, a lot of confidential computing going on there. This now opens the door to moving that into the data center more. I think it is a wonderful technology.
Yeah, certainly government is one of the areas that, sees this appeal kind of early on. The other big ones are financial services and healthcare, because they've got lots of regulatory expectations, lots of privacy requirements, and yet they're trying to share data and do, innovative things with multiple parties. So these are areas that are kind of your early adopters. But also, if you think about enterprises wanting to move to public cloud, and yet they have sensitive data, and they say, I don't know if I can trust putting that sensitive data out in the public cloud. How do I know where it's sitting, who has access to it? I think I trust the provider, but I don't know what I don't know, essentially. And so by implementing a solution with SGX, you can basically say, I don't care. I've heard Microsoft say, trust me, you don't have to trust me. And it's a great line.
That's a good one.
So they're setting up this circumstance where you can have that capability in their environment, and yet you still keep the control of your data, and it's in your hands, and that's pretty powerful.
That's great. Now, where can my customers find out more, and the listeners find out more about SGX, when it's going to be available, and the ecosystem partners? I mean, because that's the key is finding those ecosystem partners to help, right?
Absolutely. We're really just starting to talk about this on a much broader scale. We just had a big announcement that just went out this month, and really kind of blowing the doors open of the stuff we have coming. Intel.com/SGX is a great place to start for testimonials and deeper dive information and more information about the ecosystem. We've got great partners like Microsoft and their Azure Confidential Computing. I mentioned, Fortanix, and we have many others that are doing really great things. And another great place is to check out the Confidential Computing Consortium, because they've got kind of the full set of people that are working in this space.
Great. Hey, Jesse, this has been wonderful. Great new technology that really has impact to a lot of listeners, a lot of our customers. Thank you very much. This has been very informative.
Sure. Thanks for having me here.
Thanks for listening to Embracing Digital Transformation today. If you liked our episode, go ahead and give us 5 stars on your favorite podcast or video streaming site. You can also find out more on embracingdigital.com. Until next time, keep moving forward and embrace the digital revolution.